So let's talk about array prototype reduce. What is array.reduce? Array.reduce is a method that exists on our array prototype. It was introduced in ECMAScript version 5 and is supported in all of our modern browsers. Now, before we begin, array.reduce is a pretty misunderstood array method and a headache for quite a few developers. Pay close attention to the little details and you will definitely succeed with reduce. The concept of reduce itself isn't complex, but the method is just a little different to that we're used to. You can think of array.reduce as I want to take my array and simply reduce it to just one value. This could be a new array. However, that's more of a complex and advanced use case. Array.reduce is commonly used for performing things such as math expressions and equations. For instance, calculating the total of numbers. For instance, we could loop over our objects and calculate each price, giving us a grand total. That would be an absolute perfect use case for array.reduce. So let's have a look at the syntax for reduce. We would do something like items.reduce. You can see here that we have the callback function expected as a first argument, which gives us a previous value, which is our data structure. We also have the current value, again, which is our data structure. And we also have the current index, which is just a number. Finally, we also have the array. Now, unlike other array prototype methods, we cannot change the this argument. Instead, we're given something slightly different. We're given an initial value. As you can see here, I can change the initial value from void, so nothing, to something such as 0. I could also perhaps start it at 10 or any other number or value that you like. It could be a string, it could be an object, it could be an array. It's completely up to you. We could leave it at 0 just to keep things simple. Now the function arguments, as I mentioned, give you the previous, the next, as well as the index and also the array that we are iterating in. So this is the function signature for reduce. However, it gives us a reduced value back once it has finished iterating and reducing our values. So that's the syntax. We'll go and explore a very simple use case for reduce now. To demonstrate, I'm going to create a 1, 2, 3, 4, and 5, and we're going to say .reduce, and we're going to reduce these numbers by adding them up. All this requires is a simple previous plus next. Now, we're not going to set a default value just yet, but we're going to toggle it and show you the difference of how reduce behaves when we in fact do. Now, we can't really do much with this at the moment. We need to create a constant. I'm going to call this our reduced value. And what we'll do underneath is then go ahead and just simply log it out. So we'll save this out and go and check out our console. We now have the number of 15. How do we arrive at 15? We're adding all of these numbers together, but the magic happens in how reduce works and how it adds them together. This is how reduce works. We have the number 1. Because there is no default value, reduce is actually starting our previous with our first item in the array. So essentially what's happening on the first loop is the number 1 plus, and then next. Next is the next item in the array. So on the first loop, we're actually seeing 1 plus 2. And once that has evaluated, that is going to evaluate to 3. So what happens here is our previous now becomes the number 3, and we get given the next item, which just so happens to be a number 3. So we're going to have 3 plus 3 equals 6, and then we're going to get a previous. So we're going to have 6 plus next, which is 4. 6 plus 4 is 10. Then we're going to have this resulting in 10. Previous is then going to be 10, and next is going to be 5. This is also known as an accumulator value. It's accumulating the results of each callback. Now, what's also interesting is if we change this to perhaps a number 10, you can see that we can pass in an initial value. If, for instance, we do pass an initial value, our previous, in fact, starts with this initial value, and this first iteration will begin with 1. So it adds that extra iteration into the loop if we do specify an initial value. Otherwise, it will just loop through your array elements one by one. Now, what's more interesting on what's happening here is we can, instead of returning via an implicit arrow function, we could just quickly log out what's happening. So previous and next, and this will then explain exactly what I have just covered. So here we go, we can see 10 is our start value. That's the previous value on the first iteration. We then get given a number 1. We then have 11 because 10 plus 1 is 11, plus 2 is 13, plus 3 is 16, plus 4 is 20, plus 5 is 25. That's exactly how reduce is working. So one by one, it's going through each of our array items to give us a reduced single value of just 25. And the last iteration of whatever this could be, this return previous plus next, instead of going back into the loop as the previous value, it's simply returned because there is no next values. Therefore, the loop exits and gives us that last expression value, which is then number 25, returned to our constant of reduced. Hopefully that is quite a nice explanation for you. If it does make you scratch your head slightly, watch it again and again, and you will definitely get this. It is the most complex of all of these array prototype methods, in my opinion. Now, at this point, we've only considered using reduce for numbers. However, it does have many flexible use cases as it returns any kind of value type. You could also return perhaps flattened arrays or new array data structures, concatenated strings, or you could create new or merged objects, or anything else you can come up with. So that's the basics of an array reduce. What I want to do now is look at a more real-world example with you so you've got something to take away as well. Now, the first thing that we're going to look at is using array map with an array reduce, just to give you a more basic example. So here we're going to say const reduced equals items.map, and we're not going to reduce our items array directly. We're going to learn how to reduce an array of numbers, and then underneath we'll look at reducing an array of objects. So let's dive into our map. So this is going to give us each item inside our map, and here we can say return me the item.price. That's all that we care about at this point in time. So at this point, we can say, give me the reduced constant, and we can log it out and see what it gives us. And this is why I've said we're iterating over an array of numbers, is because we are creating an array of numbers from our array data structure. Now, the brilliant thing with these array prototype methods is when we're returning values, we can opt in with chaining because we are returning a value here. Instead of returning it directly and exiting our map, because we're returning a new array, we can actually just bolt on some existing methods. So we can say that we want to reduce, and we can have everything in one nice line of code. So let's go and finish off our reduce. We'll do previous and next, and then we're going to add our previous and next values. We'll hit save and watch the console, and now we have 897, which is exactly the price of adding up all three of our numbers. So that's one way that we could approach the problem by reducing an array of numbers, but how about dealing with our array of objects directly? And this is where things get more interesting. This is a completely perfect example of what we've got, and it completes the mission that we set out to achieve, to simply calculate their price. But like all things code related, the more time we spend on things, the more we can make them better. So this is why I'm showing you how to reduce an array of numbers using this technique, or just reducing an array of objects directly. And that's exactly what we're going to do now. First off, we'll start with our reduced value. We can say items.reduce. We can pass in our previous value. We can pass in our next value. Now, instead of just doing a simple previous plus next, like we did with our numbers array, we're in fact dealing with an array of objects, which means that if we were to, for example, log out our console, we'll see a printed out array of stringified objects. And this is because previous is an object, next is also an object. They are these objects as we iterate them. So how do we go about fixing this? It seems like we need to reference the price property, like we kind of did inside of our map. If we go next.price, this gets us part of the way, but you can see that we have this strange object 199299. Errors like these are what makes Array.reduce more challenging. At this point, a lot of people may give up, not know what to Google, and be absolutely stuck. But this is why I've explained to you about using these initial values, because when we want to reduce an array of objects, previous is actually going to start with an object because we're not supplying an initial value, which means if we supply an initial value of 0 and hit save, we now get 897, much like we did above. So why is this? Let's have a look. On the first iteration, 0 is given to previous, so it's 0 plus next.price. So this could be 0 plus 399, which is 0. So on the next iteration, we're going to have 399 plus next.price. So you can see how we're using a number this side and accumulating a number, but over this side, we're referencing that object property, giving us that final console log reduced. So I hope that really helps you in your journey of learning Array.reduce. This has been a tricky one for many people over the years. Now, as with all these videos, I'm going to show you the imperative way of reducing without our Array.reduce. So stick around for another minute and we'll just go and replicate the behavior of what's happening here, but we're going to write the code ourselves. So we end up with this constant of reduced here. So instead of a constant, we're going to use the let keyword and just leave it as undefined. We're going to create a previous value. However, we do not have a callback, so we're just going to simply declare it. We can say for let I equals 0, I is then less than our items dot length. We can then increment our value of I. Inside of the body of the function, we can create not an item, but we're going to create a next value because we've got our previous, but we want the next value. How do we do the next value? We simply want the next item in the array. So we're just going to start with whatever the index is. So in this instance, our previous is simply our accumulator. So what we're going to say is previous, and we're going to reassign it. Previous is equal to the previous value, which is 0. So that's the first iteration is going to give us 0. And then we're going to say next.price. You can change this to item should you wish, but we're just going to leave it as next.price to match what we've done above. Now, the only reason I've created this let reduced is because when previous has finished, we don't want to reference the value directly. We could say that reduced equals the previous value, and we can just leave all references to previous as it was up here. So let's finally go ahead and log it out and see what it gives us. So you can see that it gives us 897. How that works, it again starts with 0. Previous is then 0 plus the next.price. 399 is 0. And then on the next iteration of the loop, previous is then going to be the value from the last iteration of the loop. This is only by stylistic choice. You could use the previous value directly, but because we're splitting things out, I like to keep them all separate, and we don't want to be using something which was considered a previous value in perhaps something that should be named more efficiently. So that's it for this video. Reduce is a really nice addition to any developer's toolkit. We've looked at arrays of objects, arrays of numbers, and we've also looked at how to manually reduce items so you can think about things imperatively if you're coming from that background to a more declarative background. We've also thrown in some knowledge bombs on chaining your JavaScript operators. When they return something such as a new array, we can then chain them because we then get a new instance of an array back every single time. We looked at a very basic example and logged out the previous and next values. We've talked about the initial values and the sequence and the order in which they are executed in.